Okay, so I asked the base model, what is the capital of France? And instead of giving me the correct answer, which it is aware about, it just gave me this quiz. But this is not a bug. This is an expected behavior from a base model. And to turn it into an assistant model that we use every day, a lot of work needs to be done. The first stage is pre-training. The model reads a lot of text, for example, books, and it learns exactly one skill, which is to predict the next token. So the result of this stage is that we get a machine that is able to continue text. This is the only thing that the machine does at this stage, and it does it really well. Okay, so here is a screenshot of an actual request that I made to Qwen 2.5 base model. Now, when I say that a model is a base model, what exactly does that mean? It means that this model has completed only the first stage of its training, which is the pre-training that we have just discussed. So the only skills that it has is to predict the next token. That's why when given this text over here, this question, it just thought, well, how should I continue the given text? And it came up with this answer. So as you can see, it has all the knowledge inside it already. It just doesn't know yet that you want answers from it. Now is the time for the model to get a little bit smarter. Stage 2, SFT, which is supervised fine tuning, means that we take a lot of conversations in the form of a question good answer pairs and we show them to the model and we train it to imitate them. So basically, it's the same predict token machinery that we saw on stage 1, but now the target changes. Now, good means that the output produced by the model resembles the demonstrations. So it learns the pattern, the format, a question, and an answer. But imitation has a ceiling. Your model is only as good as your examples. And of course, it's much easier to judge than to write. Which of the two answers is safer, cleaner, and which is more honest? You can't demonstrate that. You can only compare. And this is when we need stage 3, RLHF, which is reinforcement learning from human feedback. So, how it is done? We show people two answers for the same prompt by the same model, and then we collect the votes that they gave and we train a reward model, a judge. Now, this judge is capable to score answers given by the model on itself without human reviewers. And reinforcement learning pushes the model towards answers which the judge scores higher. Moreover, there is a simpler way to complete stage 3, which is DPO, direct preference optimization. The idea is that we don't need to build a separate reward model, we don't need to train a separate judge. Instead, we take the same words from people and we train the model on those comparisons directly. So the goal becomes to push the probability closer to the winning answer and away from a losing one. And the target stays the same, human preference. And this stage leaves fingerprints. We all saw them, agreeable tone, the hedging, polite refusals. That's all are traces of the preference tuning. And this stage has a well-known failure mode because, obviously humans tend to pick answers um, that are confident and which agree with them. So that means that preferred is not correct. Okay, and now welcome to stage 4, which is RLVR, reinforcement learning with verifiable rewards. This one is conceptually close to stage 3, but with one major difference. No human judge is needed anymore because now we work with verifiable information. So, for example, if a model was tasked to write code, its output will either pass the test, okay, or it will not. Pretty simple. If it is a math problem, the model's answer will either match the correct answer or it will not. Now, for verified correct answers, we give 1 and we give 0 for incorrect ones. Pretty simple, and the goal now becomes to be verified. Okay, now let's talk about GRPO, which is an algorithm for RLVR. It was initially introduced by DeepSeek for math and coding problems. So here is how it works. We ask the model to attempt the same problem multiple times. Usually the number of attempts is between 8 and 64. Then we score the answers it gave on its attempts. We give 0 for bad answers and 1 for verified correct answers. And we also push the model towards the answers that beat the group average. And something interesting happens here. It discovers that its long and step by step attempts tend to pass more often. That's why you see the reasoning models thinking out loud, and nobody scripted that. The reward system, the reward model discovers this. Okay, so why would you learn and keep in mind all this? Well, the answer is pretty simple, because it allows you to link a behavior to a stage. So for example, if the model's knowledge is missing or incorrect, then you go take a look at the pre-training stage. If it follows the format, but the content is kind of shaky, you go and take a look at your supervised fine tuning stage. If it agrees with everything you say or it refuses too much, then you know that something is wrong with the preference tuning stage. If it thinks on a simple problem for 2 minutes, then your reasoning is broken. Now, I think that this is pretty helpful. So take a screenshot. That's it for today. I will see you the next time.